The Fukushima Daiichi nuclear disaster, on March 11, 2011, has reminded everyone of the most catastrophic nuclear disaster in human history, the Chernobyl disaster. It also raised people's concern about the safety of nuclear power. However, although there has been some potential hazard of nuclear power since it was invented, the nuclear power, without any doubts, is still supposed to be considered as one of the best energy sources. In addition, if present problems with it could be effectively solved, the nuclear power would definitely benefit the future of human race in a huge degree. Obviously, nuclear power has a series of advantages. For example, nuclear power has the lowest impact on the environment since it does not releases any exhausts like carbon dioxide and methane, which are largely responsible for greenhouse effect. Moreover, nuclear power is much more powerful, efficient, and economical than other alternative energy sources. Even though nuclear power is extremely promising, it still has some problems. On the one hand, when emergencies happen to the nuclear reactors, they will be relatively hazardous. This is because when the containment structure of the reactors are broken due to the accidents, the core of reactors will irradiate a lot of radioactive rays, which can cause the fatal damage to someone nearby. On the other hand, the waste of the nuclear reaction from the normal fission reactors can be hazardous as well, if they are not properly disposed after the reaction. This is because the chemicals contained in the waste are also relatively radioactive, so they are harmful to humans. Fortunately, there have been some probable solutions to deal with these two sorts of problems of nuclear power. To deal with the safety issues of nuclear reactors, installing the nuclear reactor safety system is an ideal option. NRSS is a very broad concept. It consists of a number of subsystems, which are all responsible for keeping the safety of nuclear reactors. Emergency core cooling systems could safely shut down a nuclear reactor during accident conditions. Moreover, this subsystem allows the nuclear power plant to respond to a variety of accident conditions, so the plant can be shut down even with one or more subsystem failures. As we know, under normal conditions, nuclear power plants receive power from off-site. Whereas, during accidents, plants may lose access to this power supply. In this case, emergency electrical systems could let the nuclear plants use built-in diesel generators and batteries to generate their own power to supply other emergency systems. In order to deal with the disposal of the nuclear waste, it is a good option to improve the long-term management of the nuclear waste. The reason why this solution is ideal is that the hazard of usual nuclear waste can last for extremely long time, varying from 10,000 years to 1 million years. One typical method of the long-term management of the nuclear waste is the above-ground disposal, such as dry cask storage. It involves taking waste from a spent fuel pool and sealing it in a steel cylinder, which is placed in a concrete cylinder acting as a radiation shield. Another attractive method is space disposal. It involves sending the nuclear waste into outer space using astronautic vehicles, thus permanently removing nuclear waste from this planet. In the future, the most feasible and effective method will be finding the applications of the nuclear waste. This is because, in this method, we can not only reduce the amount of the nuclear waste but also take advantage of the nuclear waste in a new way, which means the whole industrial chain will become more sustainable. In conclusion, we believe if two possible solutions, nuclear reactor safety system and long-term management of the nuclear waste, can be perfected and properly implemented, the present problems with the nuclear power will be effectively solved. And nuclear power would definitely benefit the future of human race in a huge degree.